So, we're very happy today to have Wendong Zhang, who is an assistant professor at the Dyson School of Applied Economics and Management at Cornell University. Wendong has published research on the U.S. farmland market, both agricultural water conservation and soil conservation practices, and papers on Chinese agriculture. And he's an editor at the American Journal of Agricultural Economics and the Journal of Soil and Water Conservation. So today he's going to be talking about his research, and we're very excited to have him. I'll let you take it away.
Great. Thank you, Lauren. Good day, everyone. So today I'm going to share a little bit about some of my recent and ongoing research related to soil and water conservation research. Um, and we're really grateful for this opportunity. And I'm also a proud PI of ongoing EDF Atkinson grant project that I will share with you a little bit as well. So before we move on, I want to give you a little bit about background about myself. So as you heard earlier, that my portfolio is a little all over the place, but among the three themes that I will work on, I want to focus on the first theme today, which is the interplay between agriculture and the environment. I also do work on farmland market, and I've done quite a bit of work last year on foreign land ownership, for example. I'm originally from China. I'm also have done quite a bit of research on U.S.-China trade war, what is the global trade implication of Chinese food demand as well. I joined Cornell Dyson School in 2022. Before that, I worked at Iowa State for 7 years. Um, Here in Cornell, I'm part of the Dyson School, which is now primarily administered by College of Business, but I also have 50% of extension appointment. So I still have a deep tie with the traditional home of Dyson School, the Ag College. For my background, I got my undergraduate in environmental science, and you can see that in my work, some of my work are actually quite interdisciplinary, that I tend to work with agronomists, plant pathologists, environmental engineers, and others in in some of the issues. And naturally, the interplay between agriculture and the environment calls for interdisciplinary research as well. So I currently I'm the Cornell PI for a grant related to anaerobic digesters to reduce methane emissions. And uh, the EDF PI is Dave McLaughlin. Unfortunately, I think Dave has run into some travel logistic issues, and we're hoping to see each other next tomorrow. So um, the interplay between agriculture and the environment has been a long-term interest of mine. And I've been working this through grad school, where I went to Ohio State and did quite a bit of research on nutrient reduction in Lake Erie. I will share some more information later on. I have also have done this related to conservation and adoption in in other countries as well, in China, and starting to look at Germany too. Some of my work are also related to collaborating with interdisciplinary researchers. I currently have research grants, especially funded on organic vegetable production, assessing technology adoptions. So this is in joint work with researchers at both at Cornell, but also Kentucky and Iowa. So before I move on, I want to give you some outline of what I'm going to talk about. And I'm happy to take any questions, especially if you have any clarification questions. Happy to take them throughout. I will also try to allocate at least 15 minutes in the end for questions as well. Um, I'm a real economist. If you have seen economists present, we tends to pack a lot of the information into the talk. So if you have any questions, please raise your hand and let us know. So I will first give you some of my thoughts on the significance of U.S. conservation spending and what are some of the goals and my own thoughts on how whether we're making any changes relative to the grant goals. Uh, the meat of the presentation will be focusing on two sets of examples where I have worked on as an economist working with other natural scientists. One is focusing on Lake Erie, and the other one is focusing on Mississippi River watershed. And you can see that there's a similar theme of connections where there's a linkage between farmer decision making and the nutrient outcomes, which impacts a lot of the general public, not only locally, but also downstream. And we start to look at my work, not only look at the source of some of the problem, where looking at the farmer's decision making, but also examines value of nutrient reduction or value of water quality improvements from using environmental economics, non-market evaluation techniques as well. In the end, I will very briefly share about what we are doing with the EDF projects on anaerobic digester adoption, as I mentioned. I have two other interesting ongoing projects. So one is related to biodiversity using Cornell's Lab of Ornithology eBird data, which is global, by the way. And I'm also having quite a bit of research on solar and agrivoltaic as well, focusing on US Northeast for now. So let's dive in. So first, if you're looking at why we care about this problem, about conservation, the US spends quite a bit of money on soil and water conservation in general. This gives you a chart prepared by Congressional Budget Office that shows, on average, USDA alone, without accounting for the state level or private conservation payments, a USDA program alone, it's accounting for about $5 to $6 billion on conservation. And increasingly, you will see the steady increase of the darker color shares, which represents working land, including cover crops, no-till, and others. So, however, if you're thinking about what are some of the goals for conservation, right? Initially, when CRP was created, the Conservation Reserve Program in the 1980s, it was one of the ways to restrict the crop supply and the acre supply to support farm prices and supplement farm income. I don't think that's the primary objective anymore. There are a lot of emphasis recently, especially on soil health, and you can see there are a lot of important work on those. And I wouldn't focus too much on this, and I do think my work related to farmland value is directly tied with this. One of the common challenges is that we have a crop productivity index, for example, for most of the land parcels, but they don't change with whatever you're doing with land. So the soil health is not necessarily reflected in the key indicator for the land parcels. So in most cases, we are looking at appraised value or sale prices for land prices. There are some indicators that if you're looking at better soil quality, then that would lead to higher yields or cheaper input costs and higher land values. But we need a lot more connection that ties with conservation and soil health outcomes and potentially with yield and land value outcomes. And increasingly, if you're looking at conservation, if you're reading the news, there are a lot of discussion on the acres of conservation practice as a benchmark on measurements of whether we are doing a good job or a better job or not. The last one to sequester carbon is also increasingly important as we are entering the carbon credits era where not only USDA is thinking about how to incentivize conservation practices to reduce agriculture's carbon emission, but also to use agriculture as one of the way to sequester carbon so that these carbon credits can be sold to large corporations, and you're seeing a lot of the private carbon credits program as well. So if you're just looking at the acres of conservation practice, this year we just had the 2022 Ag Census results out, and if we are measuring the total acres of adoption, we are seeing that cover crops nationwide has about a 17% increase than 5 years ago, an additional 2.6 million acres to about 18 million acres, and a 50% increase from 2012. This is according a summary by National Sustainable Agriculture Coalition. But I have to temper your excitement where if you're looking at the total cropland acreage in the US, we're talking about way higher than this. It's almost 250 to 300 million acres of cropland. And if you're looking at the adoption rate, it's very, very low. So even just looking at acres, my former colleague Alejandro Plastina, now at the University of Missouri, has two very interesting work. I encourage you to check it out on Choices magazine, which look at a county level, if you're examining the cover crop adoption, there's another phenomena called the disadoption as well. That here, if you're seeing any blue colors, that means that in this particular county, you actually observe less cover crops in the year of 2022 than in 2017. So they also give some potential examples of why this might be going on. And by the way, that William Suargo is an assistant professor and former student of Alejandro and myself, now extension economist at Auburn. Some of the reasons cost share payments from USDA program and maybe state level programs haven't really increased. So while we are seeing a significant increase in input costs, which means the farmers are paying their larger share, there might be a potential behavioral responses when the markets are really good. So they want to take, because this is the annual practice, they want to use these acres from either no-till or cover crops, thinking about more carefully about production. But essentially, I think these are some of the concerns that we need to pay attention. And even though we not only look at the million acres, but also look at the acreage share. So you will notice that I have one blank space. That's one of the things I want to focus on. If you're looking at one of the primary goals of conservation, at least when we initially thinking about why we are paying farmers to adopt these practices, is to solve some nutrient problem, is to reduce nutrient runoff into the water bodies, to improve water quality, both locally and downstream. And here is one sobering figures that this is the most recent map of impaired waters in the US according to US EPA. And you can see they are quite pervasive, and they are covering not only just in one pockets of the United States, but it's in many places. And GAO report also noticed that half the US waters and streams are not assessed yet, even though they're mandated for assessment as in the Clean Water Act. So I think that using this as a benchmark, we still have a lot of progress we need to make. Here's one more visible example that I will touch on in some of the summary of the bulk of the presentation I mentioned earlier. So on the top left corner, it's the Gulf of Mexico hypoxic zone. So the hypoxic zone, meaning this water body has no or low oxygen, where potentially can lead to fish kills and other ecological problems. And this is a size that potentially can reach the size of Connecticut, for example. And on the right, this is in my backyard. This is Taganic Falls. It's in Finger Lakes, where occasionally could be potentially closed swimming areas because of harmful algal bloom. And I want to remind you that this is not only a US problem, but also happening globally, not only in Europe and China, as you may already know, but also increasingly um, in the Caribbean, for example, the Great Atlantic Sargassum belt that is actually moving, inching towards Florida, and even in many lakes in Africa, we start to see similar harmful algal bloom events due to excessive nutrients as well. So again, so thinking about the goals of conservation, I mentioned if you're thinking about the cover crops adoption as a share, that in Iowa, for example, we're talking about 6 to 7% of the land are currently adopting cover crops. And we are talking about that for the target, both in Lake Erie and Gulf of Mexico, in order to reduce or significantly mitigate the impacts of harmful algal bloom, we need about 40% or less loadings from nutrients like phosphorus or nitrogen. So just in case you don't know, that Lake Erie is a freshwater, so the limiting nutrients is phosphorus. So the focus is phosphorus on the left, and Gulf of Mexico is the marine water body where the nitrogen is a limiting nutrient. So, but we are uh, if you're looking at the significant reduction or mitigation of harmful algal bloom in both water bodies, we're talking about potentially 40 to 50% of nutrient loading reduction, which roughly translate into at least 40% of the acres in cover crops or other practices that we're far away from these goals in a way. So I think that one of the message I want to mention is that if we are looking at what we have achieved, that it's useful to think about that we have 2 or 3 million acres more, but we also have to keep in mind that relative to the grand goal, in terms of acreage share, we are actually not making a whole lot of progress after decades of significant investments. All right, so what I want to do next is I want to show you some of the examples of the work in more concrete ways of my recent published work looking at Lake Erie and Gulf of Mexico and give you some examples to contextualize what I described earlier. But before I do that, if you're thinking about, for example, the cost and benefits of mitigating or preventing harmful algal bloom due to nutrient reductions or improving water qualities, that you will realize that we need to thinking about what are the potential costs for farmers, but also there's potential. What are some of the governmental budget outlays? Because especially in a current policy environment, what are some of the payments that is in the form of 50-50 cost shares, and often it's fixed cost share payments. We have also done work which trying to quantify the economic benefits of nutrient reductions. My colleague, Cassie Kling and Dave Kaiser have several influential publications which assess the current cost benefit of Clean Water Act. If you're looking at a lot of the assessments of the Clean Water Act, there's an undervaluation of the benefits coming from the water quality or improvements. In part, compared to air quality, for example, you can easily link air pollution or particulate matter with infant health or even worse outcomes that comes with a significant value that you can quantify it as a benefit through pollution reduction. And we don't have much good estimates on the value of health benefits. And Cassie and I and my colleague Sheila Olmstead have students who are working on some of the issues in a context of improved water quality. Okay, so here this is one useful interdisciplinary research framework I organize my work in. So what we're studying is sort of focusing on these different boxes. So my work look at how the policies and how in which including potential cost share payments or others that affects farmers' individual land management, land use, conservation practice adoption decisions. So my work is related to the first box of economic decisions by farmers especially in the land use or land practice adoptions, which is translated into spatial landscape outcomes at the watershed level. You can quantify, suppose you have 30% of the certain percent more land in cover crops. How does this mean for phosphorus runoff coming from this watershed? Um, and so this requires geospatial or land watershed models. And often one of the model we use is called a SWOT model, the Soil and Water Assessment Tool. It's developed at Texas A&M and USDA Ag Research Service. And this will be fed into, say, suppose you get 10% reduction in phosphorus or nitrogen loading into your studied water body. You can assess whether water clarity in the ecosystems or whether you see higher catch rates or more juvenile fish of some sort. And you can also assess the probability or the spatial extent of harmful algal blooms as some of the ecosystem services. And that requires collaboration with ecologists, for example, right? Once you gather these information, the economists will come in, again, using techniques called the non-mark evaluation to potentially quantify the benefits I mentioned earlier. How much of the improved water quality will benefit recreational anglers or beachgoers? How much of this water quality are reflected and whether to what extent on waterfront property values and what is the spatial decay? How the reduction in algal toxin or the increase in algal toxin change the wastewater or drinking water plant treatment cost, because that sometimes that the treatment plants, they don't necessarily have the right equipment to deal with the toxins, right? And through all these perspectives, that you can assess the cost and benefits or the cost effectiveness of the existing and potentially other proposed policies. So that's some of the thing again. So me as economist will look at not only the first box but also in a last box as well. Right. So here is one example that that we published in Land Economics in 2020. The first three co-authors are economists, and the other ones are ecological engineers. Right. So what we're doing is we're looking at three best mathematical practices in Lake Erie. They're all working land, so there doesn't involve a conversion of your edge of your fields into something else. So they're involving injecting or subsurface placement of your fertilizer, cover crops, or reduction of phosphorus application rate. So the current adoption rate for cover crops in Lake Erie, in Western Lake Erie basin, is about 20% when we studied. So I wouldn't go to too much, but it's essentially this the spatially explicit process-based model called SWOT that will translate landscape outcomes into nutrient loadings, right? What we're finding is that one of the thing we compared is the cost share payments versus fertilizer taxes, right? So if you're just looking at on the left figure, if you're increasing cost share payments levels and just looking at the potential economic adoption behavior, increasing the cost share payments, the current level is about $25 to say half of that. You can significantly increase the share of adoption from maybe 20% to 35% or 40%. So there's almost a doubling or one-to-one responses into the payments. But one of the message we want to convey is that most of the economic paper will stop here. That we're happy with the policy instruments. if we increase the payments rates, everything will be solved. Then one of the things we did is that we are looking at, for example, an alternative policy, the fertilizer taxes. I know this is politically very, very difficult, but I just want to show you the figure to show that how difficult, how high these taxes needs to be to even move the average application rate from 110 pounds per acre to, say, like a 90 or 80 pounds per acre. So this will be requiring like a 300% tax rate, right? So 4 times of the fertilizer prices that you're getting maybe a 20% reduction in terms of the fertilizer application without accounting for all the behavioral complexity. And I want to show you that on the left, that just looking at economic behavior may give you a rosier picture. If you're looking at adoption, if you're looking at, let me see whether I have this. So if you're translating this BMP adoption into nutrient reduction, unfortunately, the most significant outcome will actually give you not very big changes in downstream water quality because of the complexity of the watershed. So one of the things is that even if you have significantly doubled cover crops, there are phosphorus in the soils, in the lake beds, and also in the soils in the watershed. Even all the fertilizers in Western Lake Erie basins are stopped. Likely Lake Erie will at least have another 10, 15 years of harmful algal blooms as well. So the nutrient outcomes, again, we're talking about the goals of conservation. Are you just looking at the acres of adoption, or are you looking at the downstream water quality? Even you are thinking you're having a rosy outcome in the adoption, you're not necessarily achieving the corresponding water quality outcome you're hoping for. One of the other perspective we showed is, suppose you're only looking at payments. Suppose you're only looking at the payments as we are in a current regime. So that's on the right here, that you can increase the payments, the net policy cost paid by the taxpayers as a share of, as a total of government cost share payments totals increase from, say, $20 million in this watershed to 160, that the percent reduction in spring phosphorus loading because of the complexity I mentioned will actually only increase from about 1 to 2% to less than 10%. Again, remember the goal is about 40%. I wouldn't go into too much, but one alternative, for example, is to think about whether you can use fertilizer taxes as a way to gather revenue, but rather than the evil government keep all the money that you've taken away from farmers, you just use this as one of the pool that you also supplement this revenue into the source funding for the cost share payments as well. I don't have time to go into too much. I will answer questions if you have them. So we have also done work on, again, the value of water quality, as I mentioned earlier. So one of the findings is we have looked at surveys of Lake Erie recreational anglers, and we find anglers are willing to pay about $8 to $10 more per trip for 1 less mile of boating through harmful algal bloom. So there's a significant willingness to pay for the recreational opportunities. So I wouldn't go into too much of those. And through these estimation that you can find some information about welfare gain, essentially for different nutrient reduction scenarios, how the general public potential willingness to pay. I understand that we didn't ask them to actually make this contribution, so there's a potential overestimate due to the hypothetical bias. So I also want to move on a little bit more to look at the Corn Belt. especially for Iowa watersheds with a focus on Gulf of Mexico harmful algal blooms, with a focus on the first box, the farmer decision making, to give you some more similar and more complex stories. One is, again, so Alejandro and I have done analysis. We have a paper on Journal of Soil and Water Conservation, which look into the role of land tenure insecurity, look into how this affects conservation practices. But for the purpose of this study, this presentation, I want to point out that in 2017, that only 4% of Iowa farmland, cropland, are using cover crop. And the new census survey is showing that this percent is about 6 to 7%, right? So remember that we are trying to achieve about 40% nutrient reduction. And so this is still a very, very low, very low percentage, even though that if you're a half full personality, then you can argue that there might be a third increase in the acreage. But again, if you're focusing on the goal of the conservation being moving the needle for nutrient reduction downstream and reducing Gulf of Mexico, the hypoxia, we're not necessarily making enough progress, at least until now, right? So there are some very interesting provided reasons by the landowners and producers that talk about why they're not using these practices, right? So for no-till, many people selected potentially worry about not suitable for land, hurt crop yields, and for cover crops, many people worry about that this require too much time or they don't have enough days to work during the planting seasons, especially due to excessive rain in the spring and too costly to terminate. Right? One of the interesting things we also asked is, what are some of the alternative policies that you would like to see that would move the needle? Right. So where the reaction are very strong is that the tax credits one. The landowners are hoping that they can receive either property or income tax credits for implementation for conservation practices. So that's one of this last one, right? So Alejandro has also done a lot of research, interesting research about especially the net returns from producer's perspective, and finding sometimes that you don't necessarily achieve positive return. So that's part of the reason why from the producer perspective, they don't necessarily want to adopt these practices, especially when input costs are rising, as we have seen over the past few years, right? And this become a sticking point because the current program is often fixed in the design, where you have a fixed payments regardless which farmer or which land parcel you are looking at, and you are not necessarily achieving the bigger bang for the buck for where it is needed to be. One last piece of the specific research I want to share is I want to call your attention to a recent paper that I worked with grad school colleague Greg Howard at East Carolina University. The key incentive is that we are often hearing people to say that that the current USDA conservation program maybe needs more reformed, where we can introducing a lot of the specific innovation that you can offer spatially targeted payments or higher offered payments or reverse auction, where rather than paying everyone the same, you can ask the farmers to bid how much they would like to receive. Then you can rank based on how much water quality improvement they can deliver. One of the things we want to caution is that too often when we are analyzing the effects, okay, so I will skip some of the details. Okay. When we are analyzing the effects, we often look at the green box. We're looking at the cost-effective ratio of a particular program, but we lose sight of sort of information in the middle, that how much in total the nutrients you're reducing. Right. So we have in this table, in this paper, we have compared some of the standard cost share program. In scenario one is sort of the fixed payments, everyone get $50. So for example, for cover crops, and then two is you are potentially only paying the higher impact, a spatially explicit way, that in the hotspot area, you are getting the payments, but if you're not in there, you're not. And then you introduce reverse auctions where you can ask for $50, but if you ask for $20, you're more likely to get it, right? And it's some combination. We do want to caution that when you introduce more complication into the program, that the benefit cost ratio, the cost effectiveness on the per bond basis in the green box will improve compared to the current design. So there are definitely some improvements in efficiency and cost effectiveness. However, if you're looking at the participation, the participation can have a significant decline in the number of farmers enrolled in these. And when you're looking at the predicted total nitrogen reduction, that it's actually the existing program, the simplest one, can achieve the largest nutrient reduction compared to all the other more innovative ones, given the similar budget, right? And I also want to call your attention that the reduction is, say, about 500,000 pounds, right? 500,000 pounds. However, in these watersheds that in the Boone and North Raccoon River watershed that we are analyzing, the loading is about 12 to 27 million pounds, right? So in relative share, they are very, very low. That we have simulated that for any of the policy, either existing or the innovative ones, with the budget of over $3 million, that the most effective policy involving cover crops through the payments alone can only lead to about 1.2% of the nitrogen reduction, right? And remember the policy goal, 45%, right? So in a way that my message is that yes, we should, look at and celebrate the increase in acres eroding cover crops, but we also should not lose sight of what these cover crops are supposed to do. It's to lead to significant nitrogen reduction or water quality downstream, to have these observable water quality outcomes. Right. For the interest of time, I will very quickly show you some of the ongoing work in progress to give you some idea of the breadth of the work. We are currently doing work related to enrollment restrictions and additionality. So with the article forthcoming in Land Economics, the idea is that a lot of the private carbon credit program start to only pay farmers if you are doing a new practice. So if you did cover crops for 2 years, then you're doing cover crops again, you're not necessarily getting the payments. So we have some analysis there. We are currently looking at whether the behavioral aspects of the adoption matters. So we are comparing if you're receiving the message from extension professional versus early farmer adopter, from a female farmer versus male farmer, from a message that only talked about water quality, versus the message also talk about wildlife, how this will change potentially your decision making in the context of not only cover crop, but also agile field practices. These are more structural saturated buffers or bioreactor that is more permanent and last for 10 or more years. Right. So these are the agile field practices that we're focused on. I will not talk too much. We are also doing work related to landowners. A lot of the data work, including the vast majority of the USDA data collection, for example, focused on producers. But if you want to make changes, especially on the structural practices like agile field practices, you need the buy-in from landowners. And especially the landowners often are not operating landowners, and the and the 14% of the land in Iowa, for example, is owned by women landowners who are 75 or closer to 80 or above, right? So and they want the information, but a lot of the information are not necessarily reaching to them, right? So I will skip this. And with the last 2 minutes, I will mention these ongoing research. One is, again, this EDF Atkinson grant was co-led by Dave McLaughlin. We're looking at dairy farmers' adoption of anaerobic digesters. Hopefully, a year later, I will be able to share some of the progress and research output. Working with Dr. Cassie Kling, my colleague, and Amanda Rothwald at Cornell Lab of Ornithology, we have several projects involving biodiversity using the eBird data. One one consequential one that we're working on is that recently Supreme Court had a ruling related to Clean Water Act, essentially restricting what kind of a water body is classified under WOTUS rule, waters of the United States. So essentially, that potential can result as ephemeral wetlands without a consistent surface connection to the water bodies, no longer being protected. So we're looking to how does this affect migratory birds, waterfowls, and game birds as well. So lastly, I want to mention there are a lot of interest on solar. So working with colleagues, we have several published and ongoing papers on solar development and what is the impacts on land values, land use, how does whether an agrivoltaic, the dual use where you put sheep or crops underneath a solar panel could potentially work out. A key message that I want to emphasize is in these eras of the new technology adoption, whether a farm or a farmer is closer to energy infrastructure, which includes electricity transmission lines, substations, or natural gas pipelines, are significantly influencing weather and how big these technology adoption would be. So final thoughts, and I think one of the things I want to encourage you to think about is when we are thinking about conservation spending, that U.S. is doing that, right, federally and at the state level. What is the major goal, and are we making progress? Are we measuring the progress toward these goals? And related to that, USDA had almost over $2 billion of grants allocated out to the private carbon credits program. There are a lot of interesting programs going on. So are there systematic efforts to assess the efficacy of existing USDA conservation programs or the private carbon credits program? Right? I think that to understand that and against which benchmark, right? To understand that would be useful to help us move the needle and have with the grander perspective insight. With that, I will close and see whether you have any questions. Thank you very much. And this is my contact information.
Does anyone have any questions? I'll ask. I thought it was really interesting that graph that you showed of reduction in fertilizer use against attacks.
Uh-huh.
It was like shocking how sort of shallow that that slope was. I'm curious, do you have any idea whether that's like many farmers reducing their inputs by just a little bit, or is it a few farmers sort of drastically reducing their input usage? Maybe
Um,
there's like some sort of like salience thing that's what I was thinking.
right. So it's a very good observation. So if you think about, for example, your fertilizer application, right? There's a there are some aversion to uncertainty. If I worry about I didn't apply enough, then I could worry about the potential yield impacts. In Iowa, for example, in northern Iowa, many of the soil test with very high soil test of phosphorus level. And if you're looking at the nutrient application guidelines, that they don't necessarily need to apply any phosphorus fertilizer at all. But most people, many farmers still apply even at the full rate, right? So that's there are some behavioral element of that. You know, your most also this is I think this is related to the information sources as well. Many producers are getting information from service providers that your fertilizer dealer, would have a self-interest to encourage you to apply this to guarantee yields as well. Um, and and if you worry about, for example, you applied manure or other fertilizer, you worry about the efficacy of those, and that will also encourage you to continue to apply fertilizer as well. Like we do have to comment on this. This is a so we have your actual prices. You have your actual fertilizer application. What we did in this paper, we ask you how much you would apply if the prices are, say, 50% higher or 50% lower or something like that. So this is not entirely based on the observed price and quantity um, pairs.
Gotcha. Well, I guess maybe if you think that one of the problems is that fertilizer salesmen are kind of juicing the numbers, then is there like some sort of policy that would disincentivize that on their end? Like maybe rather than doing a per unit tax, you could do like a tax that like increases in your application per acre or something like that.
There are some regulations that is required that has application timing requirements that you cannot apply fertilizer or manure on frozen grounds. The fertilizer tax is interesting because this is in a current U.S. political environment that often it's politically very toxic. I do have to point out that if you're looking at, we have done general public surveys in Ohio, for example. If you're looking at what sort of the policies that people support, um, that the so people so the share of the respondents, the general public who support fertilizer taxes are even higher than those who support recreational fees when entering the parks, right? So it's depending on who you're asking, but it's the share is not like a 20%. It's we're talking about say 55% of the general public, right?
Okay, I see. I guess that leads into the next sort of thing that I was thinking about, which is it was interesting that the graph that you showed of you know, hypothetical adoption rates for different types of policies. There was like tax breaks versus cost
Oh,
sharing.
yep.
I'm curious about why you think farmers think about those things differently. Like why should a tax break be different than payments?
So I have to point out that this is only looking at the government cost outlay, right?
Oh, no, you had one more chart too, is like a bar chart.
Uh,
Um,
in
mm, I
in
think
Lake Erie or the
Let me find it because I have your slides. Um, no, one of it was it was a bar chart, and like on the far right there was like uh you know tax breaks, and then there was
Oh, okay. Yep, yep,
okay.
yep. This.
Yes, that one.
Yep, yep.
Yeah, I'm curious like why there would like in theory you could probably make all of these kind of equivalent just by moving around the numbers. Like, is there a reason why you think farmers would prefer tax credits versus estate tax or versus cost share?
Um, so this is not producers, this is landowners, and which including operating landowners or not, right? So the estate tax, I think that that people tends to overthink about this, but if you're looking at the share or the number of farms that they eventually would have to pay estate taxes, it's less than 1,000. So it's a very small share. But tax credits, this can be much broader based, and these either conservation related property or income tax credits are actually not available, right? So that's the one that is actually potentially can impact significantly that the and so all the landowner could potentially um, see the impacts. But you the congressional the research service needs to do to see whether like how big a budget impact these policies would be, right?
Gotcha. And I guess I guess you should be thinking that like tax credit would actually, save money, whereas a cost share would just kind of reduce costs of making some sort of change.
Right. So there there is a related discussion on if you're thinking about USDA cost shares, there's concerns about um, how does the whether the USDA and state level cost share money plus now the new pot of private carbon credits, do they go hand in hand? Do they crowd out each other? Right. So are they achieving the same goal, or you only have five farmers, you just switch to different source of payments eventually, right? So the tax credits is interesting because that this one is the one that get most a reaction from the landowners because that they occasionally every few years that you would hear something like that.
Gotcha. I guess I'm a little like I'm not an agriculture economist at all. Can you talk about like I guess there's landowners, but there's also like tenant farmers, like who is making these conservation decisions and, you know, is it usually the landowner?
So this is depending on the practice, right? So again, so the cover crop and no-till are the working land programs, right? So these are the conservation practice that is you make on an annual basis. That in many cases that the tenants are making potentially these practice. But we also are looking at agile field practices. These are more structural. So because this is involving converting some portion of the land away from agricultural production to something else. And in most of the case that this requires landowner approval, right? Um, and landowner increasingly, like about 80% of the Midwestern land are owned by non-operating landowners, right? So they potentially include a retired farmer, but many of them don't currently farm, right? I saw Okay, I saw
Well,
a question from Leah. what opportunities or barriers do you see to gain water quality benefits as co-benefits from increasing investments in climate smart ag programs? Is it a win-win or far more complicated? I think this is a really good comments that if you um, go back to the conservation goal I mentioned earlier, right? So increasingly, we have interest and investments into conservation practices to in order for the fifth objective to sequester carbon, right? But the practice are sort of exactly the same. So often the key poster child practice is cover crops, right? So I do see that, because of the interest on carbon, there's a potential synergy for co-benefits, the related practice that can also deliver water quality benefits. My Iowa State colleague Hongli Feng and I, we have looked at different practices that we group this as carbon only practice, a water only practice, and co-practice as well. So there are some potential synergies that you could see, but it may not be the truth all the time. So for example, to improve water quality, that one of the really effective one potentially can be the structural agile field practices that will be more permanent and you have more predictable outcomes. But because they don't necessarily directly have carbon benefits, they get even potentially less attention or less investments. Right?
Edge of field is something like planting trees or something like
Right.
that
So the
to, as a buffer for
so
your.
potentially saturated buffers where this is a corn, right? So you have this buffer where this is a saturated buffer where the structure that you're also making nitrate removal before you go through the stream as well. Or there's a wood chip based bioreactor that you go through this structure so you sort of soak up some of the nutrients. Or you potentially have a low spot pothole in your land, then there could be some constructed wetlands, or there are prairie grass that used to flow in the Midwest where you can serve as a biodiversity habitat as well, right? But many of those require, for example, this may require you convert 5 acres of your 100-acre parcel into something like this, right?
I see. And I guess there's really no benefit for the farmer to do this, so the payment would be really key.
So there is so from production perspective, you don't necessarily directly see the benefits. Arguably, if you have the prairie grass, then there are potential some co-benefits coming from pollination, but this is mainly coming from potentially, the societal benefits as opposed to the production benefits.
Gotcha. And do you think the reason why a policy like a mandate is not at all talked about here is just because it would be like so politically unpopular that it's kind of a non-starter, or is there some other reason why?
So that's definitely one of the major reasons, right? So, and if you're thinking about the Clean Water Act, the Clean Water Act doesn't have jurisdictions on non-point source pollution, right? And as I mentioned earlier, that even if you are looking at the Clean Water Act, where the Army Corps of Engineers or EPA think they have jurisdiction, they may not, right? Yeah, but
Oh, okay. Well, I think we will end it there. Thank you very much for coming. I thought that was fascinating, so we really appreciate it.
thank you. Thanks, everyone.